Okay, so welcome everyone to the presentations of the Senior Project 2. We'll be starting with group number 7. Project is Customizable ETL pipeline. It's called Enrichy for data enrichment and predictive analytics. It's supervised by Dr. Hussam Sharara. You have 20 minutes for the presentation, and then we'll have questions. Thank you.
Okay, so hello everyone. Today we'll be presenting our thesis graduation project. This is the flow of our presentation. We'll start with an overview. We'll then be talking about the pipeline details. We'll show you our testing plan. We'll also discuss our business approach, and we'll finish off with a demonstration. Okay, so starting with the overview. So if you think about it, data is the foundation behind any meaningful analysis or decision being taken, whether we're evaluating performance or making investment decisions. However, the process from raw information to something that's actually useful is still extremely manual. So data preparation takes time, it invites mistakes, and often involves repetitive tasks that slow down teams. The analysts at hand often know what they want to explore, but their true barrier is collecting this data and having it in a consistent format. And that's why without automation, the process takes a lot of time. And these issues also need technical expertise and are present across various domains. But if we focus on one specific field, and that's the finance field, these challenges become even more nuanced and complex. So real value within this domain comes from combining the different data points to show how the signals and patterns arise. So we want to combine the different sources and analyze them within a given context. So the only way to do this at scale is through automation. And that's why we've defined these 4 main objectives. We first want to automate the collection and fetching process. We want to eliminate the technical barrier, so users don't have to write code or create pipelines. We want to combine the data from the different sources under a specific and uniform format. And we want to enable meaningful financial insights by combining the different financial domains into an analysis structure that can help highlight the correlations or the relations between the data. And we've put these objectives into our proposed solution, which is a software as a service platform called Enrichy, that takes in a natural language prompt from the user, and its final output is a financial data frame that has been cleaned and validated. It does this through two key components. First, a model that understands the user's intent, and second, a deterministic ETL engine that carries out the whole pipeline, starting from the fetching of the data, its validation, and the final output to the user. Let me take you behind the scenes to give you a brief of how this happens. So this is our full architecture. We start with the LLM, which takes in the input. We have an extraction phase, which fetches the data and joins it together. A transformation phase that applies some data cleaning and quality control checks. And finally, a load stage that provides the final output to the user in his required format. We'll walk you through each of these phases in more detail throughout the coming slides, starting with the LLM ingester.
Okay, so first off, we'll start with the first part of the pipeline, which is the ingester, which is split into 2 parts, main parts. First off, the LLM, which takes in the input, which is a user human language prompt. So in this example that we've given, the user's query is that he's trying to compare between the multiple electric car companies' financial sheets and their stock prices within the past 5 years, so that he can sanity check them. So what the LLM does is it understands it dissects it dissects the prompt, and it understands what the user wants and his intent, and it comes up with the specific API endpoints. In other simplified words, what this means is it finds the sources within which we will find our needed data. It also identifies keywords so that it can compare them later on with the extracted endpoints and validate them. So why do we use an LLM? So it keeps API usage efficient, as it is dynamic. It directs the pipeline directly towards where it finds the data, and it also guides the whole pipeline process. So again, it's dynamic, so we use it. It doesn't depend on static keywords to find the data.
Okay, so then we come to the ingester, and basically it's tasked with turning the user's query into an actionable data retrieval process. It does this by first checking what the LLM has recommended and validating that it fits within our context and that our data sources actually support it. And once that request is confirmed, the ingester automatically connects to the various data sources or APIs. It scales according to the user's request. And the output of this stage is the raw financial information placed in a data frame, making it ready for further processing down the pipeline.
Okay, so as can be seen here, this is the whole integrated LLM and ingester. So it takes the user query. Currently, we have two APIs implemented, Polygon and Alpha Vantage. So it finds within both of them what data do we need. And then the ingester's job is to take these endpoints, and it just extracts the data.
Okay, so going back to the query provided initially, this is the output that you will see from this phase. So for example, for electric cars, we extracted the stock datasets. We have Tesla, we have Rivian, and Lucid. We also extracted some key financial documents like the balance sheet and the income statements for the same said group. Now we're ready to pass this on to the validator stage.
Okay, so now with the second part for our pipeline, which is the validator, it's the machine learning component we have in our pipeline. First off, with the architecture, the validator is composed of two units, the union and the join, and we will dive into the details of each component in the next slides. So starting off with the union, the goal for the union is to combine the input tables that we get from the ingester into a unified dataset for each domain. So if the ingester got like two datasets for stocks and two datasets for balance sheets, the union combines them into one dataset for stocks and one dataset for balance sheets. How this is done, we use an embedding called the ephemerit. This embedding is used to calculate a compatibility score between the datasets. And if the compatibility score passes a certain threshold, then the union is performed. Let's see how this is done. Looking at this example, we have two datasets. Each has 6 columns. 5 of those match. So there is a high compatibility score. Passes the threshold, then the union is done, as we can see. Now, that's the samples that we get from the ingester. It's 2 datasets, all about stocks. Pass through the union. And then there is a whole union dataset for stocks from the 2 inputs. Now I'll pass the mic to Yusuf to explain the join.
Now that we have passed the union stage, we have vertically combined the single domain datasets into one. The next challenge would be that we want to connect multi-domain datasets into a single one. So there's what the join comes in. The purpose of the join is that we want to horizontally combine the 2 data sets. And how we do that is we have different sources, and each source has different, they don't have perfect keys, so we can't use a normal join operation. So that was where an XGB model comes into play, where it computes the compatibility score for each row pair combination. And we filter out the low scoring matches and select the high scoring pair to join. This would be much more clear in the next example, where you have 1 stock row on the left and about 5 balance sheet rows on the right. The model checks all combinations and gives a score to each combination and selects the highest one. Here you have the top right row. This is what the join will do. And returning back to our original use case, where we had the union dataset and the ingester fetched balance sheet and the ingester fetched income statement. By the end, the model would do a row pair compatibility score for each, and we will end up with a final dataset with all domains connected together.
Moving on to the transform phase. So this is the architecture of the transform phase. We take two inputs. We have our combined data frame from the validator. We also take a list of enrichment features from the ingester. They go through data cleaning, feature enrichment, then we output a report, and we also output data. So first of all, we start with cleaning. Among other things, it ensures that columns have the appropriate data type. So for example, integer columns are actually parsed as integers and not as strings. We also delete columns with null ratio that's above a certain set threshold. And we can also apply validations on columns. For example, we can enforce that a column is positive, non-negative, and we also have cross-column checks. Finally, we sort by ticker and timestamps for presentations to make it good looking for the user. And this is all driven by a configuration file. We go to the enrichment. This is primarily 3 steps. First of all, the LLM translation. We provide our list of enrichment features and information about our data to the LLM, and it generates an enrichment DSL object that tells us how to enrich our data. Now, since the output of the LLM isn't exactly perfect, we put the DSL object into a DSL validator to make sure the format and the parameters are correct. And after that, we take that DSL object and we give it to our enrichment engine. The enrichment engine applies the features. So for common enrichments, we have a standardized implementation, for example, with simple moving average. But sometimes the user might want an enrichment that's not very common. So in this case, the LLM will generate code. And in order to run the code securely, we run it inside of a sandboxed environment. This is the output. So in our example, we generated a column called SMA10. This is simple moving average. This was not in the original data set. Okay, so we have the data, but the user wants to download the data. Maybe they want to put it into an external program. So here the user has mainly 2 options. They can either download it as CSV, they can also download it as Parquet. In addition to this, they can also download a report. We have it in PDF format, which gives a summary, and we also have it in JSON format, which has a lot of technical details, metadata, and much more information.
Okay, so for our product to be market ready, it has to be thoroughly tested. And so we've gone through with the following testing phases. We started with smoke testing. So what this basically means is testing each component on its own within the pipeline. So we started by testing each as in the LLM through feeding it certain inputs and checking that it does the required intended feature. And we've done so with the following phases. We've also made the fallback scenarios so that whenever an unexpected input is fed into each component on its own, there is a fallback scenario that happens so that the whole process doesn't hallucinate. Then we've started integrating each component with the one after it. So we started checking that the workflow is correct between each 2 components on their own. And so we've connected the pipeline components and tested moderate complexity requests to confirm that the behavior is as intended. And we focused on correctness and stability, not yet. We didn't start stress testing by then. Lastly, to make sure we've done, to polish it, we've done the system testing, which is basically the testing that it's as if we've employed the whole project in real life with all the unpredicted behaviors. So we've fed it complex prompts and unpredictable behavior and high-level workflows were tested. And we've made sure that the fallback scenarios were working correctly within the whole pipeline. And so we've had the following limitations within our whole product, which with the first being large batch requests, since we are limited in the ingester by the API rate limits. So we weren't able to get data from more than 50 plus companies, as the limited our whole pipeline, and also inconsistent coverage. So missing or incomplete data for some companies' time windows caused join operations to drop rows and columns and reduce the final data size.
Moving on with our business plan. So financial institutions heavily depend on clean and well-structured data, yet for now, analysts and experts in the field spend much of their time cleaning the data, fetching the data themselves, and this is a very big pain point for them. So the market gap we've identified is that we need a fully automated and trustworthy pipeline that alleviates that pain point off of the analysts. And for the competitive landscape right now, the existing players do cover some of the problems, but each of the following have specific problems. For local providers, like the EGX, they offer feeds with no validation, and we have general purpose LLMs, which are excellent at analyzing the context and intent of the user, but are not trustworthy for the results. And you have premium platforms like Bloomberg, which who are very powerful, but they're very costly, and they're not optimized for ETL workflows. So the advantage of our product is that we combine both natural language processing with a deterministic machine learning pipeline capable of producing multi-source data sets. And next we have the customer segments. We'll focus mainly on the B2C and B2B, where you have individual users, which include analysts, consultants, and students. And you have the institutional clients. We have the big firms like banks, financial institutions, fintech companies, and consulting firms. I'll leave Hussein with the following slides.
Okay, now with the second part for our business plan is the cost analysis. Basically, our money will be divided into three main components: the financial APIs, the cloud hosting service, we chose AWS, and the LLM model usage that we use to process the input of the user. Financial APIs, we opted to have 12 APIs to cover as much data as possible from the mid and high tier. And as you can see on the screen, all of that totals to a 6.5K cost per month. Now, moving on with the pricing model, we opted to have three tiers: the standard, the premium, and the business. The standard is being used for students, and it's there to make the purpose of the project is to have like non-technical users use our product, and that's the students trying to learn new stuff. For the premium is more related to freelancers and experts in the domains of finance and data science. And for businesses, it would be used as a VPC component in their companies. Last slide is the expected revenue for the first year. We target to have 200 standard users, 50 premium users, and 5 businesses to a total of 255 users, and a total revenue of 9.95K, which makes us profit approximately 53% per month. Now I'll leave Yaman to demonstrate the demo.
So this is the demo. You're first of all presented with our beautiful logo. You can put your query here. You can also choose a validation profile. You click on Run Pipeline. It shows you the steps, the ingestion, validation, and transformation. So it goes through them one by one. You get a preview of the data. You can scroll through it. You also get an ingestion report. This shows you all of our API calls, what they outputted. We also get a validation report. It shows our union operations, our join operations, much more information about the validation. And finally, we also get a transformation report. The user can download the data either as CSV or Parquet, and they can also download the report either in PDF format or JSON format. That's it. Thank you.